Hi everyone, my name is Stéphane Chmielewski and I'm the Chief Information Security Officer and Head of Operations at Finology, a Luxembourgish fintech. I would like to share with you today how we approach the issues of digital transformation in the financial services industry, the DevOps automation principles, and how we integrate security within our CI/CD pipelines. I will first come back to the contextual elements that require working now in a more automated mode, as well as the answer that DevSecOps can offer. I will then talk about the DevSecOps principles before specifying how the implementation of DevSecOps can be achieved from a technological point of view. I will have the opportunity to answer some questions that you may have at the end of this speech. Digital technologies are gradually transforming all of our industries, and the financial services industry is no exception. Companies are increasingly adopting modern ways of developing their solution and applying new software development practices, like Agile or DevOps. These practices make it possible to develop, test, correct, and deploy faster than traditional development methods and improve time to market. However, it's becoming increasingly difficult to keep up with the pace in terms of security and to guarantee the compliance of these practices with regard to a regulatory framework that is getting tougher and more complex. As you know, cyber threats have evolved exponentially with new types of increasingly sophisticated attacks. It becomes critical with all these elements to implement practices that resolve the tension between more digitalization and sufficient security. Embedding security within DevOps practices and CI/CD pipelines has implications for company culture, organization, and tools. The adoption of DevSecOps practices is very structuring for a company. This should first lead the organization to reassess its compliance framework and how the compliance measurement is carried out in terms of KPIs. To avoid the phenomenon of silos, it is also important to work with integrated teams, that is to say, by integrating the security of DevSecOps team within the DevOps team. The DevSecOps team can thus coach and influence development choices. DevSecOps make it possible to have a unified process within which the passage from development to testing and testing to deployment in production is automated through a CI/CD tool with the integration of also automated security controls. Like any change process, it can take time, and therefore integrating security into DevOps practices is an iterative process. DevSecOps principles are built on DevOps automation principles by adding a layer of security to maintain the confidentiality, integrity, and availability of data and systems. As DevOps allows to deliver smaller and more frequent releases, DevSecOps must allow to integrate into this mode of operation by following on agile methodologies. Then, One of the keys to a successful transition to DevSecOps is obviously to be able to automate the security tests and control as much as possible. Another challenge for DevSecOps is to be able to influence the work of developers enough to avoid introducing security vulnerabilities. This issue is as much cultural as it is technological. From a business point of view, the introduction of a DevSecOps type practice should ensure a continuous level of compliance over time. Finally, the training aspect of engineers is an important topic which must continue to be addressed and reinforced in order to continue to face and adapt to new threats. So, how do we integrate DevSecOps, and what kind of practices should we put in place to automate security within DevOps and CI/CD pipelines? We will now approach the technological part of DevSecOps and of the implementation by detailing what control to put in place, and especially when and in what way. One of the first subjects that must be addressed is the management of secrets, to be sure to properly manage the passwords and the various certificates that will be used in the development life cycle of your products and applications, and this automatically. Another important aspect will be to integrate a systematic and automatic code review called static application security testing to detect coding errors and check the quality of the code. After the code review, the application should be evaluated after being launched to identify potential security vulnerabilities in the web application and architectural weaknesses. The objective here is to check that the application does not present any vulnerability when it is running. Another important element to take into consideration is the fact of using application in the form of Docker-type containers. It is therefore important to carry out regular and automatic scans of these Docker containers through the CI/CD pipelines to avoid deploying outdated applications. An interesting development brought by technology is to be able to manage the configuration as it was some code. We call that compliance as code. That is to say, to generate the configuration of the systems automatically, to test it against the security requirements, and monitor changes automatically through the CI/CD pipeline. A last important brick of a DevSecOps approach is to integrate an adapted monitoring, as well as the ability to test via penetration testing that the application or the system remain secure, and this obviously automatically. So now let's look at each of these points in a more detailed way. One of the first building blocks is obviously to ensure that secrets, passwords, and certificates are managed correctly, as it is one of the main causes of cyber attacks. To avoid storing password in clear files and also avoid multiplying password repositories and limiting management errors. One of the DevSecOps best practices is to use an integrated secret management system to make the link with your infrastructure, whether in the cloud or on-premise, with the possibility of easily integrating it into your CI/CD pipeline. As cybercriminals are becoming more adept at discovering the credential of end users that developers sometimes inadvertently leave accessible within their applications, a secret management tool like Vault provides a way to manage and maintain application secrets outside of the application in a way that serves to significantly enhance the overall application security. A tool like Vault integrates very well with CI/CD tools. We use a tool called Harness, by the way, as an integrated solution for continuous integration and deployment. And this kind of tool, like Vault, will allow you for secure and efficient password management while using automated deployment solutions. It's obviously also an interesting tool for managing the secrets of your infrastructure of any type. A high availability Kubernetes cluster in our case, whether it is on-premise or in the cloud. Web and mobile application, due to their complexity and the limited budget allocated sometime to their development, often contain a lot of vulnerabilities. It is therefore natural that they are the preferred targets of hackers. The source code audit of your applications is important, as you want to detect and remediate their vulnerabilities during the development phase. The sooner a vulnerability is discovered, the less expensive it will be to fix. Using a tool like SonarQube to edit your code is inherently non-intrusive, so you can safely scan your most critical applications without risking their performance. Such an audit allows you to detect a large number of vulnerabilities present in the source code of your applications. A SAST tool like SonarQube is particularly interesting because it tells you the exact location of a vulnerability in the source code. Within a CI/CD pipeline, you can scan your source code for known vulnerabilities using static application security testing. The CI/CD tool will automatically check the SAST reports and compare the vulnerabilities found between the source and the target branches. A dynamic audit consists of using a scanner to interact with the applications, as a hacker would do on the internet, by sending a large number of malicious requests to the audited application in order to find vulnerabilities. A dynamic analysis security testing vulnerability scanner can detect a number of vulnerabilities that can be discovered using a source code audit, obviously, but without achieving the same efficiency. Where this kind of dynamic vulnerability scanner stands out is in its ability to discover configuration issues relating to the web server on which the application is installed. An open source tool like OWASP Zap is inherently intrusive. It can damage your application, obviously. It is therefore preferable to dynamically scan an application in a pre-production environment before going to production. The advantage of this kind of tool is that it can be easily integrated into a CI/CD environment to automate the different tests and to automate tests of this type before going into production. The presence of malware in some Docker Hub images is not a myth. Some images have already circulated, some surely still circulate, and others will come. It is important to systematically check the presence of vulnerabilities on the images you use, and furthermore if it is one of your creation. Lucky for us, there are tools to make our job easier. Claire is this kind of tool. It's a tool that scans Docker images and reports known vulnerabilities. It can be used to prevent vulnerable Docker containers from ever seeing the light of production, as it can be easily integrated inside a CI/CD pipeline. Setting up security scan is a bit tedious, but its configuration in CI/CD workflows can prevent some serious flaws without doing actively anything. Scanning Docker images is like an antivirus software. It's clearly not enough to be confident about security as a whole, but it's still essential. A tool like Claire will tell you if there are known vulnerabilities in the software your container uses. Conformance testing is a non-functional testing technique to determine whether a system meets prescribed standards. The English terms used are compliance testing or conformance testing. Most software development teams perform analysis to verify that standards are correctly applied and implemented. Often, their members work simultaneously to improve standards, which in turn leads to increased quality. Compliance testing ensures that the output of each phase of the development cycle meets agreed requirements. A common problem is environments that crash when multiple developers apply incompatible changes. One way to solve this problem is to define a resource tagging strategy, for example with the role and creator tags through a tool like Terraform. Once you have defined the strategies, a tool like Terraform Compliance can be used to automatically check that the strategies are respected and that your infrastructures and application are still compliant. Penetration testing has obviously become an important part of the development process. However, most developers do not know how to properly test their application for security, or believe that their operations team will take care of this tedious task. Additionally, checking for a serious security issue should raise a red flag and prevent that version of the app from seeing the deployment. After deployment into production, security testing should continue by creating automated security attacks for penetration testing or API testing, making sure your application and your infrastructure cannot be hacked. For example, a tool like Ubuntu can search for vulnerabilities in Kubernetes clusters using, for example, internal scan, network scan, and remote scan. A tool like Ubuntu can be used interactively or, more importantly, as an automated remote penetration test of your cluster integrated inside a CI/CD pipeline. As we end, I want to recap a little bit on the key things I have shared. In order to successfully implement DevSecOps, you need to think heavily about automated testing. This, as well as empowering your team, is fundamental to achieving your goal of implementing DevSecOps. Finally, one of the principles of DevSecOps is to be prepared for threats, always. Thanks for your time, and I will welcome, obviously, some questions if you have any. Thank you.